So let's have a code walkthrough to the solution. Let's start off by creating an array. So int array, call it ARR, and let's insert some values in this array. 11, 6, 3, 9, 14, 66, and let's say 2. So now let's call the merge sort. Merge sort, this method we are going to create. So let's pass array and the lower bound, which is 0, and now the upper bound. So let's create a variable to hold the length of this array. ARR dot length, and now let's pass the upper bound, which will be length minus 1. Let's create this method, and here this I here will be the lower bound. So let's replace it with L, and the J is the upper bound. So let's replace it with U. If the lower bound is less than upper bound, so if L is less than U, then find out the middle element or the middle index. So to calculate the middle index, we will add L and U and then divide the value by 2. And now we will call merge sort to partition this array into 2 halves. So first pass the array. The first array will start from L till M, and the second array, let's call the merge sort for the second one, and pass the array, and it will start from M plus 1 till U. This will keep dividing the arrays until we get single element arrays. And then we will start merging them. So let's create a method merge that will merge 2 arrays into one array, 2 subarrays into another subarray until we get to the final array. So let's pass array and the lower bound and the mid index and the upper bound. Now let's create this method merge. So in this, we are going to merge 2 subarrays, right? So let's create 2 subarrays first. The one having, let's say, length n1 and the other one having length n2. So let's take n1, and this will be m minus l plus 1. So this is the length of the first array, and n2 is the length of the second array, which is upper bound minus m. Now let's create these arrays with these sizes. So int l new int of size n1. And now the other one, let's call it int r of size n2. We have already taken L, so let's replace it with left, and let's call this one right. So now let's copy the data to these temporary arrays. Let's take for loops. This first one is, let's say, starting from 0 till n1. And let's insert the elements in this array. So li or left I equals to ARR L plus I. In the merge sort method, we are calling merge sort twice, but we're not collecting the data actually in 2 different structures. And here we are doing that. So we are getting all the data that is related to the left part, left partition into the left array, and the data belonging to the right partition into the right array. So right, it will be ARR m plus 1 plus j. And now we are going to merge these temp arrays. So let's take the pointers. Int I starting from 0, int j starting from 0, and k starting from the lower bound. So k equals to L. Now a while loop. While I is less than n1, and j is less than n2. This is the case. And then we're gonna check which one of the element in these two these two places are smaller. So Li is less than right j. So if the left one is smaller, then add this element at ith index to the array k. Increment the I, else we will pick the element from the right subarray. So arr k equals to right j. And then let's increment the j. And finally, after placing the element at the right position, increment the k. Now the two cases when one of the array completes but there are still elements in the other one. So if I is still less than n1, then put all the remaining elements of the left array in arr. So left I, keep incrementing the I, and also keep incrementing the k. And now same for j. If there are still elements left in the right array, if j is less than n2, then get all the elements from the right array and put them in this solution array. So write j, increment the j, and increment the k as well. And with this, we have implemented the merge sort algorithm. Now we just need to print the elements of this array, the solution array. So let's come back to our main method and let's take a for loop that will iterate over this solution array and will print it. So we've already taken it in a variable, and now let's print the elements sys out and arri and give some space. And now let's run this program. Let's have the console view and see we're getting all the elements in sorted order.